one is quite unusual. It's relatively bright, meaning that it has, if it's a solid object, has a diameter of 20 kilometers. You usually see a cometary tail trailing behind it.
The Interstellar Comet 3, I/ATLAS, has shaken astronomy to its core. Its glowing tail carries unmistakable traces of water, drifting intact across deep space for millions of years. This discovery overturns long-held beliefs about how fragile molecules survive between stars. Publicly, scientists call it a breakthrough. Privately, leaked notes suggest agencies are withholding parts of the data. Some believe the water signature is too perfect to be natural. Could 3I/ATLAS be carrying more than frozen ice? And why are officials so careful about what they release? The story is just beginning. Shattering every rule of physics. We thought we knew. Deep space should kill everything. The radiation levels between stars would fry any living thing instantly. Cosmic rays bombard objects for millions of years. Temperatures hover just 3 degrees above absolute zero. Nothing organic should survive out there, especially not water. Then 3I/ATLAS showed up and broke every rule in the book. On July 1st, 2025, astronomers at Chile's Deep Random Survey Telescope spotted something moving wrong. This wasn't behaving like normal comets. Its path screamed one impossible truth. This object came from outside our solar system. The math was crystal clear. This interstellar comet was travelling at over 130,000 miles per hour. It followed a hyperbolic orbit that could only mean one thing. This frozen chunk had been born around a distant star. Scientists were shocked by the first observations. The orbital mechanics didn't match anything in their databases. The retrograde trajectory suggested this comet had survived a journey lasting possibly 7 billion years. It had travelled through the galactic thick disk. No known object should maintain structural integrity across such cosmic distances. But here's where things get really wild. NASA immediately pointed every available telescope at this cosmic intruder. The SPHE-REX Observatory began scanning the comet's composition. It used its 102-band spectrophotometer capabilities. These infrared wavelengths are impossible to study from Earth's surface. What came back in those first readings made scientists literally stop what they were doing. Alien water. Massive amounts of H2O vapor streaming from the comet's coma. This NASA discovery sent shockwaves through the astronomy community. Water shouldn't exist in interstellar space. The deadly environment should have destroyed every water molecule eons ago. Photodissociation and cosmic ray bombardment should have wiped it out. Yet there it was. Pristine water, identical to what fills Earth's oceans. But this water was older than our entire solar system. In a stunning revelation that rewrites astrophysics. Textbooks. The data from 3I/ATLAS's tail confirms water exists in deep space, surviving against all odds. The SPHEREX data revealed something even more mind-blowing. The comet's nucleus contained not just water ice, it had abundant carbon dioxide sublimating at specific temperatures. This indicated a well-thermally processed object. This wasn't random space debris. This was a processed remnant from another planetary system. It was carrying alien chemistry across impossible distances. Ground-based telescopes around the world swung into action. The James Webb Space Telescope joined the observation campaign. It used its near-infrared spectrograph to analyze molecular signatures. The detail was unprecedented. Every major observatory on Earth focused on this single target. Everyone understood what was at stake. For the first time in human history, scientists were analyzing actual extraterrestrial chemistry in real time. The spectroscopic analysis revealed carbon dioxide to water ratios. These match solar system comets perfectly. The deuterium fractionation patterns showed isotopic signatures. These were consistent with ice formation in protoplanetary disk environments. Every measurement confirmed something incredible. This water had formed through identical processes happening throughout the galaxy. Harvard scientist Avi Loeb immediately called for enhanced monitoring. He noted that any interstellar object deserves scrutiny for unusual behavior. The detection methods were pushed to their limits. Astronomers raced to collect data on this ancient cosmic visitor. They had to work fast before it vanished forever. The water detection was revolutionary enough, but when scientists realized they were looking at chemistry identical to what flows through your veins right now, the implications became absolutely staggering. But how is this even possible? 3I/ATLAS carries the same water that's in your body right now. The chemical analysis revealed something incredible. It rewrote textbooks overnight. The isotopic signatures weren't just similar to Earth's water, they were virtually identical. Scientists measured the deuterium to hydrogen ratios using high-resolution spectroscopy. They analyzed molecular vibrational modes. They studied how the water responded to solar heating through photodissociation rates. Every single measurement matched terrestrial water perfectly. This was the definitive proof, the data point that would make the headline. 3I/ATLAS's tail confirms water exists in deep space, and it is fundamentally the same as our own. This alien water discovery proves something that breaks all rules of interstellar chemistry. The comet was literally carrying the same H2O molecules. These molecules flow through your bloodstream right now. They had traveled through the harshest environment in the universe. They survived for potentially billions of years. The James Webb Telescope's infrared spectrograph capabilities uncovered something even more extraordinary. Layer upon layer of complex organic compounds were preserved within the comet's ancient ice matrix. Each wavelength revealed different chemical fingerprints, hydroxyl radicals, carbon monoxide ice, even trace amounts of methanol and formaldehyde. This wasn't just water delivery. This was a complete astrobiology toolkit. It was frozen and preserved through cosmic time. Scientists were baffled by the preservation mechanisms. Interstellar medium conditions should have allowed the sublimation of volatile compounds within millions of years. The cosmic microwave background radiation alone should have provided enough energy to break molecular bonds. Yet 3I/ATLAS maintained its chemical integrity across distances measured in parsecs. The comet's thermal processing history told an incredible story through its outgassing patterns. Spectrographic analysis revealed that 3I/ATLAS had experienced gradual heating. This happened in its parent system's Kuiper belt analog before gravitational ejection. The specific molecular ratios told the tale. Abundant CO2 but depleted CO concentrations. This painted a picture of ice evolution over geological timescales. It happened in an alien circumstellar environment. This unprecedented discovery means the universe operates on chemical convergence principles. The fundamental physics of molecular cloud collapse works everywhere. Protoplanetary disk evolution follows the same rules. Cometary nucleus formation produces nearly identical results. This happens regardless of stellar metallicity or formation epoch. Water formation processes that created Earth's oceans are happening everywhere, all the time, throughout galactic history. The isotope geochemistry provided additional shocking evidence. The D/H ratios measured in 3I/ATLAS's water vapor matched Vienna Standard mean ocean water values. They fell within measurement uncertainties. This convergence across interstellar distances suggests something profound. Nucleosynthesis processes in different stellar environments produce remarkably consistent heavy water abundances. Mass spectrometry data from ground-based observatories detected trace noble gas signatures. These were consistent with solar nebula analogues. The xenon and argon isotope patterns indicated formation within a protoplanetary environment. It was chemically similar to our own system's early conditions. Every measurement confirmed that the processes creating habitable worlds are universal phenomena. The molecular cloud heritage became evident through dust-to-gas ratios. These were observed in the comet's tail. Silicate grain compositions matched interstellar medium samples collected by space missions. This proved that this object retained pristine materials from its birth molecular cloud. This ancient cosmic visitor carried chemical signatures spanning from stellar nucleosynthesis through planetary system formation to interstellar ejection. NASA scientists confirmed that 3I/ATLAS's tail demonstrates how water exists in deep space as a stable compound. This happens when properly shielded within cometary nuclei. The discovery validates theoretical models predicting widespread water distribution throughout galactic disk populations. But the most mind-blowing revelation was still coming. When researchers calculated what this meant for life throughout the galaxy, the numbers became so large they had to double-check their math multiple times. Why this single discovery? Just multiplied the chances of alien life by millions. The discovery that 3I/ATLAS's tail confirms water exists in deep space doesn't just verify H2O, survival in interstellar environments. It validates the most explosive theory in astrobiology. Scientists call it panspermia. The implications will blow your mind. If water can survive million-year journeys between star systems, then amino acids can too. Nucleotide bases can make the trip. Potentially even extremophile microorganisms could hitch rides on these cosmic vehicles. Here's what changes everything about extraterrestrial life probability calculations. Every time an interstellar comet impacts a terrestrial exoplanet, it becomes a potential biosignature delivery system. The chemical payload isn't just water. It's pre-formed organic compounds that took billions of years to evolve in other stellar environments. Planets don't need to develop complex chemistry from scratch anymore. The mathematical scaling becomes absolutely mind-blowing. Our Oort cloud contains approximately 1 trillion cometary nuclei, according to current models. Gravitational perturbation studies suggest that typical planetary systems eject 10 to 20% of their original cometary populations. This happens during giant planet migration phases. If every G-type star system follows similar dynamics, then interstellar space contains roughly 10 to the 20 wandering chemistry laboratories per cubic parsec. Population synthesis models indicate the Milky Way's stellar disk has produced approximately 400 billion stars over 13.8 billion years of galactic evolution. Even conservative estimates suggest quadrillions of interstellar objects are currently drifting between star systems. Each carries unique chemical signatures from their birth environments. The galaxy functions as a massive chemical mixing network. Orbital mechanics simulations reveal that gravitationally unbound objects follow hyperbolic trajectories. These intersect habitable zones around different stellar populations. Monte Carlo modelling suggests Earth-analog planets receive 50 to 100 interstellar impacts per billion years. Each collision delivers pre-evolved organic chemistry. This bypasses millions of years of local chemical evolution. But here's the absolutely shocking twist that scientists discovered when they dug deeper into the data. The water in 3I/ATLAS isn't just similar to Earth's water. Computer models reveal it might actually be Earth's water. Some of the molecules streaming from this alien comet could be the exact same H2O that was ejected from our own solar system billions of years ago during the late heavy bombardment. This comet might be carrying Earth's ancient ocean back home after a multi-billion-year journey through interstellar space. The discovery also revolutionizes astrobiology timescales through what scientists call chemical inheritance. Traditional models assumed each planet required independent development of complex organic molecules. This happened through random processes spanning geological epochs. But interstellar chemistry delivery transforms life emergence from a statistical accident to an inevitable consequence of planetary system interactions. Biochemical analyses show essential biomolecules like ribonucleotides and amino acids can form naturally in cometary ice via radiation-driven chemistry. Laboratory simulations reveal cosmic rays generate complex organic polymers over millions of years, turning interstellar comets into mobile prebiotic laboratories. Large impacts can launch rock fragments with microbes into space, where frozen comet-like environments protect them, potentially seeding distant planets with life. Extremophils like Deinococcus radiodurans survive cosmic radiation and millions of years in cryptobiotic states. On a galactic scale, even rare microbial transfers could propagate life across star systems, creating interconnected biospheres without requiring independent origins. The discovery that established 3 I/ATLAS's tail confirms water exists in deep space was revolutionary enough. But there's something absolutely terrifying about how we almost missed this universe-changing evidence completely due to a countdown that nearly cost humanity its most important lesson about cosmic chemistry. But what if this near miss reveals an even more disturbing truth about what else we're missing? The terrifying time limit. The detection confirming water exists in deep space within 3 I/ATLAS's tail signatures happened during a race against time that shouldn't exist according to current astronomical survey capabilities. This interstellar messenger was discovered just 122 days before reaching perihelion. This created a razor-thin observation window. It nearly caused humanity to miss the most significant extraterrestrial chemistry detection in scientific history. Scientists were shocked by how late this discovery occurred. Current sky survey programs like Linear, Catalina, and NEOWISE are designed to detect potentially hazardous asteroids. They spot them weeks or months before Earth encounters. But interstellar objects follow hyperbolic trajectories that make them nearly invisible. They remain hidden until they're already approaching the inner solar system. We're essentially flying blind to cosmic chemistry deliveries. The crushing time pressure triggered the largest coordinated astronomical mobilization ever attempted. Ground-based observatories across 6 continents immediately redirected their observation schedules. The Atacama Large Millimeter Array changed its targets. Keck Observatory abandoned ongoing programs. The Very Large Telescope shifted focus. Dozens of smaller facilities joined the effort. Every available telescope hour became precious. Space-based assets joined the emergency response. The James Webb Space Telescope interrupted its planned deep-field observations. NASA's SPHEREX mission diverted from its all-sky survey protocol. Even classified military surveillance satellites were reportedly tasked with tracking 3 I/ATLAS. This happened through Department of Defense scientific cooperation agreements. The mobilization resembled wartime resource allocation. But here's the truly terrifying reality that keeps astronomers awake at night. Current detection methods can only spot objects like 3 I/ATLAS when they're already past the outer planet orbits. By the time we notice these cosmic messengers, they're practically racing past us. The observation window shrinks by the day as they accelerate through perihelion. Then they head back toward interstellar space forever. Orbital dynamics calculations reveal the brutal mathematics of interstellar object encounters. 3 I/ATLAS reached maximum brightness for only 6 weeks during solar approach. Ground-based spectroscopy became impossible once the comet passed within 30 degrees of the Sun. This happened due to sky positioning constraints. The total useful observation period lasted less than 4 months. This was barely enough time to confirm basic chemistry. Detailed molecular analysis was nearly impossible. Scientists estimate that dozens, possibly hundreds of similar interstellar visitors pass through our cosmic neighborhood undetected annually. Sky survey programs miss 90% of objects smaller than 100 meters diameter. Comets. following trajectories that don't bring them close to the Sun, remain completely invisible to current detection systems. We're missing a constant stream of alien chemistry samples. These could revolutionize our understanding of galactic biochemistry. The missed opportunities are staggering. Each undetected interstellar object is lost access to the chemistry evolved over billions of years in distant star systems. Metal-rich population-worn compounds, organic remnants from primordial stars, and potential biosignatures pass unnoticed. Some objects may carry more exotic chemistry than 3I/AT-LAS, including polymers from young systems or processed materials from former biospheres. Technological limits, telescope availability, weather delays and equipment issues further restrict observations. Current surveys spot roughly one interstellar object per year, yet models predict 10 to 100 enter the inner solar system annually. Up to 99% of cosmic chemistry deliveries go unstudied, leaving vast galactic chemical diversity unexplored. The race to study 3I/AT-LAS before it vanished forever exposed critical gaps in humanity's ability to intercept cosmic chemistry deliveries. But what happens when the first mission actually succeeds in catching one of these alien messengers? Space race to intercept the next alien messenger before it vanishes. The breakthrough proving 3I/AT-LAS's tail confirms water exists in deep space triggered classified rapid response mission development. This represents the most ambitious interstellar chemistry project in human history. NASA's Jet Propulsion Laboratory began immediate work. The European Space Agency and international partners are actively designing spacecraft capable of intercepting future interstellar objects and returning alien materials to Earth for laboratory analysis. These missions are no longer theoretical. Engineering teams are prototyping propulsion systems, sample collection mechanisms, and orbital insertion hardware, all specifically tailored for rendezvous with fast-moving cosmic visitors. The technological demands push current space capabilities to their limits, but the scientific payoff could definitively answer whether life exists elsewhere. Spacecraft must remain on constant standby, ready to launch within 30 to 60 days of detection, compressing traditional decade-long mission planning into months. Conventional chemical rockets lack the speed for such missions, while ion drives are too slow and solar sails face payload and trajectory limitations. Nuclear thermal propulsion offers the most promising solution, delivering the high thrust and specific impulse needed to reach objects traveling at 20 to 40 kilometers per second. Navigation and sample collection present unprecedented challenges. Interstellar objects follow unpredictable hyperbolic paths influenced by planetary gravity, requiring precise, late-stage course corrections. Spacecraft must capture ice and dust, traveling over 50,000 miles per hour using hypervelocity systems like aerogel collectors and electromagnetic traps. Cryogenic storage below 150 Kelvin and radiation shielding are essential to preserve fragile, organic compounds during return to Earth. Early detection is critical. The Vera Rubin Observatory, scanning the sky every 3 nights, could provide years of advance notice, allowing rapid spacecraft assembly and deployment. Pre-stocked mission components, tested propulsion modules, and validated instruments reduce development time from over a decade to under 18 months. Private aerospace companies, including SpaceX and Blue Origin, offer rapid launch capabilities, complementing international infrastructure. Successful sample returns would allow Earth-based analysis of materials from other star systems, including chemical signatures, organic compounds unknown on Earth, and isotopic ratios revealing stellar formation conditions. International cooperation is essential, with NASA, ESA, and Asian space agencies sharing tracking, communications, instruments, and launch resources. Culturally, intercepting objects like 3I/AT-LAS demonstrates humanity's ability to study galactic chemistry without faster-than-light travel. Each future interstellar visitor will carry unique molecules from distant stellar environments, offering glimpses into different epochs of galactic evolution and potentially alien biological processes. The discovery that 3I/ATLAS's tail confirms water exists in deep space marks the start of a new era. Instead of sending missions across stars, we can now prepare to receive chemical messengers from other worlds, bridging cosmic distances and connecting Earth to the wider galaxy through the molecules that sustain life. The water that flows through your body, fills your glass, and sustains all life on Earth now has confirmed cosmic cousins travelling between the stars. The data from 3I/ATLAS's tail confirms water exists in deep space, not as a rare accident, but as a universal phenomena connecting every world, every star, every possibility for life throughout the Milky Way and beyond. The universe isn't empty. It's full of the same chemistry that created us. It's waiting to seed new worlds with the ingredients for biology, consciousness, and perhaps even civilizations we have yet to meet. This universe-changing discovery means that when you look up at the night sky, you're not seeing distant lights separated by impossible emptiness. You're seeing a living network of worlds connected by chemistry, linked by wandering molecules, united by water that travels between stars, carrying the seeds of life itself across the infinite cosmic ocean that connects us all. What do you think? Is 3I/ATLAS carrying water that originally came from Earth billions of years ago? Or are we looking at truly alien chemistry that just happens to be identical to ours? Let us know what you think. Share your thoughts with us in the comments section. Remember to like, share, and subscribe for more. Also, click the next video showing on your screen. You will enjoy it.